that I completely neglected to talk about PA1 on Monday. I was so excited to get into swing classes and stuff. So yeah, I got PA1 graded over the weekend. You have grades and comments and stuff like that. I was like so thrilled with what I saw on people's submissions, right? So everybody did what they were supposed to do and had almost all of the fraction class working, if not all of it. If people ran into issues, it was generally with dealing with the division by zero thing, right, which is tricky, not technically speaking, but there's just, you got to get it just right. And so that caused a bit of issues in a few cases. And one or two technical issues. For example, in some cases, people were modifying the argument to the add method, sort of using the argument as a temporary and adjusting it, and that has unintended side effects. But as far as working with objects, defining a class, getting to the fields that you define and so on, everybody seems to have that nailed already, which is like really amazing. Because that's really like the core of what we're after in the beginning of this course is fluency with classes and objects and the whole object-oriented mindset. And it feels like people are already there. So that's really cool. Which means I don't feel bad about giving you PA2. which oftentimes is really over people's head in the beginning. And I think in this case people are where they need to be working on PA2. So yeah, I was really happy with what I saw there. I think people are in good shape. Let me show you my fraction class. I don't know how many comments I have in it. Probably not a lot. Possibly none.
Escape characters.
So this is an older version of this, which is why it's got control M's at the end of the lines. So class fraction, right? You only need two fields, numerator and denominator. Some people chose to use a flag to record undefined. That's fine. In this case, I just decided to stick the denominator equal to 0 if it was undefined, and to just constantly look for that. It's probably cleaner if you use a flag, actually. So my constructor, I set the numerator and denominator accordingly. And I always keep the denominator non-negative. So if the denominator is negative, I just invert the numerator and denominator. Basically multiply by -1/1, which doesn't change anything. If the denominator is 0, I went ahead and set the numerator to 0. I don't know why I did that. And if the numerator is 0, I force the denominator to a 1. So when I try to print 0 over something, it'll just print as a 0 instead of 0/2, for example. And then I call a reduce method to put it into reduced form. That's Euclid's algorithm. You can construct with just an integer and it sets the denominator to 1. That's not a biggie. So the two-string method, if the denominator is 0, doesn't matter what else is going on, I return nan. And in some cases, 0/0 was printing out as 0/0/0 instead of nan. And it was usually because the logic was getting kind of complex. And in some cases, people weren't returning as soon as they might. So they would say, if the denominator was 0, do this. And then the next thing would say, if the numerator is 0, print out 0. Right? And it would ignore the fact that they'd already found the denominator was 0. So here's a two-line version. If the denominator is 0, return nan. Otherwise, return either the numerator or the numerator/denominator. And I'm just using a ternary there to say if the denominator is not equal to 1, add the /denominator. I got a comment on that line. Get numerator and get denominator. So those are the accessors. We don't need mutators. My Euclid's algorithm was really long, so some people had like a 3-line version of this. You can do this recursively. This was spelled out in horrible detail. So I have my temporary numerator and denominator. If you're dividing by 0, don't have to do anything. Otherwise, make the numerator positive. If it's negative, the denominator is never going to be negative, so I don't have to worry about that. And I switched around numerator and denominator. Didn't have to do that. right? Because the algorithm is resilient if you have things in the wrong order. But I switched them around anyway. And then find the remainder and loop until the remainder is 0, doing that 2-step move the arrows around. And then just divide the original num and denom by the positive GCF. And that completes your reduction. So what?
I had to return the int, but you don't have to do that.
Okay. Yeah, so you could make a GCF method that returns an int and then divide that in your reduce. And that's a little cleaner way to do it, I think, because then it breaks out that behavior if you want to do something else with it.
I think I just did that in the actual constructor.
Yeah.
Having all the division happen in there.
Yeah, and if since you only have to reduce in the constructor, you can do it all in there. That works. And then the 4 arithmetic operations, so if the denominator is 0 on either argument, I just return an invalid number 1 over 0. Otherwise, do the cross multiplication common denominator and return a new fraction. Subtraction is the same thing, but subtract. Multiply is simple because you just multiply tops and bottoms, and division you do those in the reverse order. So you swap the second one. And in each one, the first line handles undefined. So if anything is undefined, it'll return a 1 over 0, which is undefined. And then 2 double, same thing. If it's undefined, return nan. Otherwise, do the division and return that. And most people, right, like I said, I saw versions of this that are just as good or in some cases better. So this was the bigger test case that I used on it, if you're curious. So I made 3 fractions, printed out each of those fractions, and then did some multiplication that requires reduction, subtracted a fraction from itself, which should give me 0, and then made a 0 and did some things with that, added, multiplied by other fractions to make sure that works, converted something to a double, and then added something to itself 4 times. And this was where I started seeing issues if you were modifying the arguments using that as a temporary. These kinds of things will start to blow up. And then various non-numbers, so various versions of undefined things, and just making sure those are undefined, making sure they 2 double as undefined, and making sure when you operate with those you get undefineds. So any questions about PA1?
Can you show us how to handle the division by 0?
Sure. In what context?
Like you mentioned, like most of us got like divided by 0 wrong, and how to handle that.
Like for example, I had everything except for when it was 0 over 0, it prints 0 instead of n.
Okay.
Like this would be a good example.
So when you construct, right, if your denominator is 0, I set the numerator to, let me see before I talk. If the denominator is 0, I set the numerator to 0. I don't know why. But, so I'm using denominator equals 0 to say things are undefined. So in toString, for example, very first thing I check is this number defined? Right? If it's undefined, I just return NaN and I'm done. I don't do anything else. So if it's 0 divided by 0, 1 divided by 0, -5 divided by 0, it doesn't matter. It's that divided by 0 I'm picking up. Okay, the denominator is 0, it's not a number. That's what I return. Same thing happens in 2 double, right? First thing I check is the denominator is 0, and if it is. And then any time that I operate, right, I check is the denominator 0 or is the denominator of a thing that I'm multiplying by 0. And if either of those are true, I can't return not a number, right? I have to return a fraction, so I return the fraction 1 over 0, which subsequently, if you were to try to print, would say the denominator is 0, I'm going to print NaN. Yeah.
Well, if either of those have a denominator of 0, even if you're multiplying or dividing, it'll multiply out as either something over 0 or 0 over 0. Because
Right.
So, do you need to have that if statement?
Only because, so probably not.
I don't
Let's
think I
see.
did when I did it.
So 0, so if the denominator is 0,
In the add function.
this will
subtract
definitely
function.
become 0 on the bottom. Same for subtract. Multiply would be 0. So how about division?
Yeah.
It might be if you're,
Because if the denominator, when you take the reciprocal of
yeah.
0, then you'll end up with 0 over something.
Yeah.
Yeah, that's something.
Yeah, so 0 over 1 divided by 1 over 0 would be 0 over 1 times 0 over 1. I think it'll give you 0 over 1, which is a 0. But this should technically be undefined because I was dividing 0 by infinity.
Yeah.
So yeah, you need to check for division, but you're right, that's the only one. All right, does that help? Okay. So other questions, comments?
Are we ever going to use this fraction class again?
Oh, you might. I don't think I'd planned on it, but plans change,
Now that I've
yeah.
asked
Now that
about
you've
it.
mentioned it.
Right.
Yeah, I mean, so we already did a linked list of rectangles, right? But we could do a linked list of fractions. That would be a cool thing to do. And make rectangles with fractional dimensions.
Mixed number.
Yeah, which would be really cool because there's some things that,
It's easy to convert mixed numbers to fractions.
Yeah, that might be a good way to learn about generics.
yeah,
Fractional
Yeah.
class that can run.
that's true.
Make a rectangle that can run generics.
Yeah. So yeah, don't delete it. All right, so let's play with Eclipse.
Okay.
You had a question, comment?
Well, okay. Are you gonna go over, you said you're gonna do something for lab 2, you need to do, for the third experiment, you need to go over something about running things and checking at the same time.
Oh, that's for lab 3. I mean lab 3.
Oh,
That's not for the current lab.
there was a thing with lab 2, if I can ask.
Mm-hmm.
Lab 2 experiment 3, it wants us to have the length and light and input number that changes.
No, it shouldn't say exactly that, but that's close.
But I just couldn't think of how to, like, at a low level, I mean, yeah, just abstractly, I couldn't think of a way to do that.
So in this experiment, the user runs your program which asks how long to delay between blinking. The user enters a number specifying the delay. The program then runs an infinite loop from
Oh,
experiment 2.
I did-
So you're only setting a delay in the very beginning, and then it's fixed for eternity.
That's a lot easier.
Yeah.
I think we were trying to find a way to stop it, like
Yeah.
putting a key and stopping them.
That's going to be hard at this
I
point,
think we
other
were
than
trying to
Control
do
C.
Okay, so
Right.
that's what you want, just Control C.
So Control C to get out of it is fine, yeah.
Okay.
Now in lab 3, we try to do what you're describing, which is while it's blinking, you can type in another number, hit enter, and it'll change. Or you could type a command like, exit, and it'll like shut down. And that's going to require that we have 2 threads, 2 processes running simultaneously inside your one program. One that's doing the blinking, the other one that's waiting for input from the user and saying, okay, change the blink rate to this, and somehow passing that to this first thread so that the blink rate adjusts. And so we'll be doing multi-threaded programming in here, and that'll be one of the experiments we can use to explore that.
Yeah, we tried to look it up, and it looked pretty simple, but it was like, we didn't know exactly what was making it so it would run at the same time.
Right, right. And it is pretty simple to set up. It can be very complex, but it doesn't have to be. But it gets you into a whole lot of interesting theory related to things like deadlock. And you can find yourself in situations where you have two threads that are pretty straightforward, but through some situation you didn't imagine, this thread is waiting for the first thread, and the first thread is waiting for the second thread, and they're both stuck. Right? And this can be very common, particularly with larger systems that are developed organically. You get into these deadlock states, and it can be really hard to debug sometimes. So we're going to play around with some of that. We'll talk about different versions of deadlock. We'll talk about the dining philosopher's problem and all kinds of fun things like that. And we'll also talk about some of the potential problems of having multiple threads in terms of data corruption and losing all your money from the ATM and stuff like that. So that's going to be a whole set of topics down the road. But we don't have to worry about it yet. Not yet. Soon and often. All right, so let's talk about debugging in Java. Did we do this? No, okay, that's what I thought. Okay, so let's just make some code. So here's my main method.
I can already see where the issue is, bro.
You would?
I can already see where the issue is. Why? Let's see what we want.
All right, so here's some random code, deliberately ugly. And what the heck, we'll make a rectangle class too. So it's complaining right now because it doesn't know what rect is. So I could import it from CSS, but I don't want to do that. Or I could create a class rect. Let's do that. So here's a class named rect. Alright, so this is a crazy rectangle class. I don't have a valid constructor. So and while you're working with classes, right, so I'm using everything tabbed, right? So there's my main, there's my rectangle. Couple of things to note. There's a little red, I don't know if you can see it up here, there's a little red mark here, which means there's at least one error somewhere in here, which it was complaining about the constructor. And I've fixed the constructor over here, but I haven't saved this file yet, and there's a little star next to my file name that usually tells you you made changes that haven't been saved. So as soon as I save this with a Control S, that little red mark goes away from here, which tells me everything is fine now. So I can go ahead and run this, and it doesn't do anything obvious.
We haven't set
but it doesn't seem to exit either.
J less than 20, so Y less than 20.
Yeah,
that's
yeah.
infinity.
Oh, I thought you'd be.
Yeah. All right. So so let's debug this. Okay. So main thing for debugging, you want to change your perspective. So go to Window Perspective, Open Perspective, and there should be a debug option. If it's not here, look under Other. Okay. So debug. There's a little bug next to it. And when you want to run your code, you're going to say run and debug instead of run. So let's put some breakpoints in here. So let's put a breakpoint right at the beginning of our loop. And I'm just going to double click over here in the margin and set that little spot there that says there's a breakpoint. And I'm going to run debug. And it starts running and it stops when it gets to here. So the main thing you're going to want to work with is this window up here that shows you your variables. So I had a variable args, which doesn't have any stuff in it. I've got count, which is a 0. And I've got r, which is a rectangle, and I can expand that. And I can see its color is purple, its height is 7, something's minus 42, its width is 12. And if I don't care about my rectangle, I can close that up. So every object that I have access to from my current location in my execution stream, I can see up here, right? And you can follow, right? If we had we should do this on the linked list class. If you have a linked list, right, in the node, you can follow that through pretty directly. In fact, if I can find the linked list, let's do that next. So under run, we can also single step. So we can step with an F5 or an F6 into or over. So I'm just going to F6 a few times. And you see I'm getting new variables popping up here. So I is 0 and j is 0. And now I've got an x. And j is 2, j is 4, 6, 8, 10. But immediately you can see what's happening. J exceeded 10. And it's like, so what's going on here? So I drink my coffee and I finally realize that, yes, I said I less than 10 instead of j. So we can change that. And let's just stop this. And let's debug it. And let's do some F6s. And now after j was 8, the next time through, it went back up to my original outer loop, reset I, started running j, and so on. And so if I believe that works, I can say resume, and it'll run and exit eventually, or not. I don't have it doing anything, though.
Is there another group you got?
Maybe it's more broken.
Could be.
Doesn't look like it should be though.
Yeah, except that didn't grow out. So let's, well, let's just run it.
Just having the variable counter is a useful way to say.
Yeah, yeah.
It is.
So I is 9, and so there's the exit point.
Oh.
So, and it says terminated. Yeah. So that's good.
Sweet.
All right, so if you want to get out of here, just change your perspective back to your regular Java perspective. I need to change my workspace, though, to wherever my linked list code was. We didn't do linked lists in here, did we? We did it from the command line. All right, we'll play with that another time. You would?
Yeah, I think that's what happened.
Okay.
For a second, I thought you meant we didn't work with linked lists at all.
Oh.
I mean,
No.
this class, not yet. But
Yeah. All right. So questions on that? It's pretty straightforward, right? It's a little less mysterious perhaps than GDB. And it's nice because you're inside Eclipse, which at some level knows what you're trying to do. It understands syntax, it understands Java. And so doing things like expanding variables inside objects, right? And if that's another object, you'll see what kind of object it is, and you can expand that and get to its areas, and so on and so forth. Makes life a whole lot easier. When you delete things, you always have an option of whether you want to actually delete it from just Eclipse or you want to actually remove it from your hard drive. So if you really want it to go away, you can say delete it on the disk as well, and then it's gone. Otherwise, it just removes it from Eclipse, but the files are still there. All right, so let's talk about Gooeys. Let's talk about Swing in Windowbuilder. So there's two pieces what we're going to be playing with. One is Swing. The other is Windowbuilder. And for us, they're going to go together. Okay, Swing is a collection of classes that do things related to making graphical displays, putting up a frame, buttons, checkboxes, windows that you can put text into, catching mouse movements, things like that. It's a whole bunch of classes, okay, and collectively it's called Swing. It's not the only way to do this. There's lots of other packages that are available. We're going to concentrate on Swing. And if you know how all these classes work, if you know what all the different types of objects are, how to construct them, you can sit at a command line and you can write Java code that creates Gooeys. Okay, so when I first started playing with graphical interfaces in Java, right, I didn't know any better, that's the way I did it. And got really long code, right, so it's like 10 lines of code to produce a frame the way you want. And you've got to do things like say, okay, what kind of frame do I want? What should the title bar be on it? Right, so what's a frame? A frame is just, you know, a window like this. Okay, it's got a title bar that might have some text, could have an icon. It's got these little buttons at the top for closing or maximizing or reducing. It might have a toolbar, it might have different sections and so on. And the color of this section is different from the color of this section, and there's a certain font being used, and all of this stuff is variable. Okay, there's defaults for most of it, but you can also tailor it. But you need to specify some things like what are the dimensions of this frame, okay, height and width. You might want to say where should it be positioned, or should it be maximized, and so on and so forth. And then if you want some buttons on there, like here's a button that I can click on that changes me to the debug perspective. Here's a button that creates a class. There's also a drop down that lets me choose what kind of class I want to create. Okay, and there's classes for doing all of these things. And there's methods in these classes, and there's fields that you can set in these classes to control all these different characteristics. So if you learn all of this, you can create Java code that sets all this stuff up for you, right? Makes it happen. But that's kind of a pain. It's a lot of learning curve to get your first object to pop up. So there's tools like Windowbuilder or NetBeans or other things like this that will do all that sort of detailed work for you. And so Windowbuilder is a drag and drop way to design Gooeys. You can say I want a J-frame, you can drag a button over and place it where you want, and you can click on the text and change it by typing, and you can right click and say let's change the color of this, and so on and so forth. Okay, it's a very standard approach to designing Gooeys. If you use Android Studio, it looks and feels like the same kind of experience. It's drag and drop, and you can click on something, get to its properties, and so on. So we're going to work with Windowbuilder on top of Swing. I think at some point there's great value in knowing how to put these things together by hand, but it's a whole lot faster using a tool like Windowbuilder. It makes your code a little easier to follow what's going on. And I'm not interested in this being a swing class, okay? I want this to be a Java class. I want it to be an object-oriented data structures class. So we're going to take advantage of Windowbuilder in this case to help us make Gooeys. But we can always go back and we can look at the code and see what Windowbuilder is doing for us. All right, so if you go under Help, there's an option for Install New Software. That's where you can find Swing and Windowbuilder. So you have to choose basically what repository you want to work from. So work with, and I'm just going to say, for me, I've got Oxygen, so Oxygen. And under Filter Text, you can say Swing. And it's not going to find anything for me because, well, it's not going to find much for me because I've already got Swing installed. So just for demonstration, I'm going to uncheck this box which says Hide Items Already Installed. And let's see what it finds. It's fetching my children. Okay. So under General Purpose Tools, Swing Designer. So that's the one you're going to want to install. You can also do the documentation if you want. Alright, so if you do this on yours, you should see those options pop up. So click those and go ahead and say Finish. That'll install the Swing classes, and then you want to do Windowbuilder. And you can probably do all of these, right? Definitely do the core, core UI. I would just check all of these. None of them are terribly big as far as I can tell.
This is something you do once. You don't.
This is just a one-time thing, yeah. Once you do this, these are basically a part of your Eclipse setup. And then if you change workspaces or whatever, it doesn't matter. This is still available. So yesterday, this was behaving really badly for me. It was crashing, and it was hanging, and all kinds of things. So we'll see how this works. It's one of these things that feels almost like it's a little more reliable under Windows than Linux, which I hate to say. But let's see what happens. So let's make some Gooeys. So I'll just call this Gooey Intro. And I'm going to say File New, but instead of making a class, right, I'm going to come down here and I'm going to say Other. And under Other, look for Windowbuilder. Okay, so normally we open up under General. Scroll down, you should have a Windowbuilder option. And under Windowbuilder, I'm going to say Swing Designer. And under Swing Designer, I'm going to say JFrame. Okay, so open File, New, Class, go down to Other, Windowbuilder, Swing Designer, JFrame. And now it just wants the name of my frame, so I'll just call this my MainFrame. And I'll go ahead and say Finish. And it writes some code for me. Got something crashing in the background. I don't know what. So it writes some code for me, and we don't really need to worry about what all this stuff means, but I'll tell you anyway. This is my main program. Okay, public static void main, same as usual. It's creating what's called a runnable. This ties in with threading because when we're doing Windows, we're doing multi-threaded coding. Okay. Which it kind of makes sense we have to do because you've got code running and then somebody comes along and clicks on a button and something happens, right? So how would you do this in C? How would you create some graphical display? There's some way to do that. And sit here and move a ship around, but then when somebody clicks on a button, fire a missile off the end of the ship.
Event loop.
Without an event loop, though. Because we haven't said that yet, but yes.
Yeah, I don't know if that's what this means. You could have something constantly checked to see if variables change or not?
Yeah, so worse than that, right? If all you had was a straight procedural language without some notion of events or interrupts, right? You have to constantly check to see if the button's pressed, right? So move the ship and update your time and your roll and update the position of the ship and redraw it and then check to see if the fire button's pressed. And if it's not, go ahead and do an update again. Now check to see if the fire button's pressed. It is, so launch into your thing to display a missile, right? And the more things you have on your interface, the more work you have to do to see if some event has occurred, okay? So everything we do in here is going to be event-driven, and it's fundamentally a different paradigm from straight procedural programming. But it's like what you do in 270. If you've done 270, you remember interrupts. What do? You set up some interrupt handlers. You put a vector at location 8 or 18, and you say, when this pin goes high, I want you to stop what you're doing and go over to this other section of code and start executing. And when that section's done, I want you to do a return. Okay? So your main loop in those 270 programs was really just, branch to myself. It was a no-op, basically. And you're just hanging out waiting for events to happen. Okay, so that's what we're going to do with Gooeys when we're making swing objects. It's all going to be event-driven. And so our main program basically creates a new one of these my MainFrames. It's this class that I'm defining right here. So it creates a new frame. And apparently there's a method called setVisible. And by setting that true, it's going to make the frame visible. Right? So I can hover over this, and there's some documentation. SetVisible takes a Boolean, show or hide this window depending on the value of the parameter. And if you're really good, you can actually scroll through all of this. And if something goes wrong, it'll print out a stack trace. And what does it do after it creates the frame and makes it visible? Nothing. It exits. So my public static void main is going to exit almost immediately. It's going to create one object, run a method from that object, and then it's gone. And in PA1, right, once your main program exited, that was it. Your program was done. You came back to the command prompt. But in this case, even though the main program exits, the Java program is not going to be finished. Right? And it's because we've created a new thread that's taking care of handling events, looking for events, and then responding to events. All right, so that's the main program. Here's my MainFrame constructor. And it does a few things, which we also don't have to worry about. So it says, what should we do when the frame closes? We should exit. What are the dimensions of this? It creates something called a JPanel. That's sort of a container inside the frame that we can drop widgets onto. It sets a border, it controls a layout, it adds it to the content pane, and that's about it. So all this code was written for us, right? And we can run this, and we get a little frame. And we can resize it, and we can right-click on the top and get our usual action menus. I got virtual desktops, so I can pin it to all my desktops if I want. And you can maximize it, and you can demaximize it. And I can hit the X, and I can close it. And when I close it, everything exits. Right, because this was set up.
So how do you set it up so it wouldn't exit on return? On the main, right?
Oh, on the main?
Yeah,
There's no return.
I mean, it is returning from here because it falls off the end of the earth. I mean, I can put a return.
Could it be about the event queue? What's going on?
Right, so I've already returned. But it's this new runnable, so this is basically creating a thread. All right, so we've got a frame, right? Let's do something with it. So down here at the bottom of the window, there's two tabs. One says source, the other says design. Source is what you see here. It's just bare Java code. If you click on design, and if you're lucky, it switches over to this view. So here's the window that it's going to create. And suppose I wanted a bigger window. I can come over here and I can resize this. And now if I go back to source and I look at my code, it's changed this line of code to make my window bigger. So these two tabs are basically giving you the same information. Okay, this is a graphical view of it, a visual view, and the source is actual Java code. And we can do anything we want in this view. We can change things, we can change the color, we can drop components in here, and so on and so forth. We got to be a little careful what we do with the source code view. If we randomly start making changes to the source code, we can munge this, and it'll give us some horrifying exception. And I don't know if I can munge it now that I actually want to. But I don't know. Let's see if I can. It's one of those things that like breaks all the time when you don't want it to. And I probably can't break it right now. Yeah, I'd manage that.
Put the content pane beneath everything. Equal the actual initialization.
This say again?
If you put the initialization of the data panel under that,
I think that will cause a compile error.
so it won't actually break through this.
But I don't. Yeah. But anyway, it'll happen eventually, and so you got to be a little careful how we monkey with the code directly. All right. So what can we do here? We've got a visual display of how our system is set up. Okay. We've got a property window, which lets us control things about this. So for example, I can look at the background, and the background is basically a light gray right now. If I click on this, I can, make some horrifying background like that. And my source code has been changed. It added a new call to a method called setBackground. Right, and if I run this, sure enough, there's my window with my background. So we can pick whatever properties we want. We can change the foreground color, we can change the border, and so on. And there's also a button up here called Advanced Properties, which shows you even more stuff that you can change. So the main things you're going to change are bold-faced, but you can change what the cursor looks like when you're in this window, some of the details of how graphics gets rendered, and so on and so forth. All right, so we've got properties associated with whatever we select over in this window, and then we've got a palette. And the palette is the collection of things that we can choose to put into this frame in this case. So for example, I can come down here to J button, I can click on that, and I can come in here and click, and I've got a button. And it's bold-faced, the word new button. It's already selected that text for me because it knows you probably don't want the button to say new button. So you can change it. So this is button 1. And now if I run this, there's my frame and there's button 1. And if I size my window differently, my button changes size. But it doesn't do anything. And if we come back and we look at the source, here's where the button came from. It created a J button, right? It constructed it, called it button 1, and then it said add button 1 to the content pane, which was this J panel, and put it on the west, which is why it ends up right here.
Oh, okay.
If I drag it over there, it'll say put it on the east. All right, so that's our initial setup. What I want to do next, tomorrow, is look at layout managers, how we control where things are placed in a frame, and then I want to start looking at some of these different components, buttons, checkboxes, text fields, see what those are all about. I want to step back and sort of look at each of these things as a class in itself. So there's a JButton class, there's a JFrame class, and so on. And then I want to get into how we actually use these things. How do we connect clicking a button, say, with executing some piece of code? And it's very straightforward. If I double click this button, it will write some code for me, and whatever I put in here, that's what's going to be executed when the button gets clicked. Okay, it's really, really rapid development at this point. So we'll play around with that, we'll look at more event handlers, and then eventually we'll start talking about graphics, how we can actually do some displaying of information by lighting individual pixels or drawing rectangles or things like that. Okay, so this will be the next number of classes. Quick announcement, so Friday I'm not here, I'm out of town on business. So I changed Lab 2 to be due at noon on Friday. So during Friday's class time, instead of coming in here and my being available to help you, use that as time to finish up Lab 2 if you need it, okay? Or to get started on Lab 3, and I'll post Lab 3 before then. Make sense? All right, see you next time then.